Hi, my name is Gina, and I am going to be talking to you about probability distribution. So, a probability distribution is a table of values showing the probabilities of various outcomes of an experiment. Your random value, which is usually written as x, is a variable whose possible values are numerical outcomes of a probability experiment. There are two types of random variables, that is discrete and continuous. A continuous random variable has an infinite number of possible outcomes that are unaccountable. It's represented by an interval on a number line. A discrete random variable can only take a countable number of values. So for example, decide whether the random variable x is discrete or continuous. If you let x represent the inventory of milk at a grocery store, you can see that this is discrete because you can count the inventory for the milk. Another example is to let x represent the volume of water in a 32-ounce container. This example is continuous, and the reason for this is because the amount of water can be any volume between 0 and 32. A discrete probability distribution lists each possible value that the random variable can assume. A variable is said to be random if the sum of the probabilities are equal to 1. The mean of a discrete random variable is given by the sum of x times the probability of x. Your standard deviation is given by the following formula. So now I'm going to do a very long example, and that is to use the frequency distribution to construct a probability distribution and find the mean, variance, and standard deviation. So I'm going to be looking at the number of children per household in a town. So your children equal your x, and your households are your frequency. So first, you want to construct a frequency distribution table by using the given data. This is basically just making a chart out of it. So you have your x, and then you have your frequency, so your children and your households. Then you want to find your sum of your frequency. So looking at the data, what you want to do is add the numbers of your frequency so that the sum of your frequency is 150. Then you want to find your probability of x, which is by dividing the frequency by the sum of the frequency. So looking at your data again, you want to add another column for your probability of x. So to find this, you want to divide your frequency by your sum. So 24 divided by 150 is 0.16. 33 divided by 150 is 0.22. 42 divided by 150, 0.28. 30 by 150, 0.2. And 21 divided by 150 is 0.14. And then looking at this, if you add the probability of x, you can see that this is random because it equals 1. So now that you solve for your probability of x, you can now solve for the mean by using the given formula, the sum of x times the probability of x. So now you have your chart again. You want to add your column for your probability, your x times your probability of x. So to do this, you want to take your x value and you want to multiply it by your probability of x. So 0 times 0.16 is 0. 1 times 0.22 is 0.22. 2 times 0.28, 0.56. 3 times 0.2, 0.6. 4 times 0.14 is 0.56. So your mean is equal to 1.94. So I just rounded that to the nearest tenth to get your mean of 1.9. So now you want to find your values of x minus your mean, x minus the mean squared, and x minus your mean squared times your probability of x. So taking your chart, I'm going to add the next three columns of your x minus mean squared, and x minus the mean squared times your probability of x. So this column will give you your variance. So, to find x minus your mean, you're going to do your x value minus your whole mean down here, your sum. So to do that, you get negative 1.94. And I just went across the columns. It's a little easier to calculate. So you're going to square your negative 1.94 to get the following. 3.7636. You're going to take that number and you're going to times it by your p of x, your probability of x, which is 0.16, and you get a very large decimal. Then you're going to do the same thing for this one. You're going to take your 1 minus your whole mean to get a negative 0.94. Then you're going to do your value of x minus your mean, and you're going to square that. So negative 0.94 squared, another large decimal, and then you're going to take your value for this and multiply it by your p of x, which is 0.22, give you an even bigger decimal. I'm not going to bore you with that. I'm going to skip for each one. So for the next one, you get the following values, and then you just keep going down. Okay? So then you want to find your variance by finding the sum of your last column. So add up the following values for your last column, and your variance equals 1.6164. So now that you have your variance, you can find your standard deviation. So you do that by basically taking your square root of your standard deviation. And you get 1.3. And that is rounded to the nearest tenth. So what does this mean? So knowing the following information, that your mean is 1.9 and your standard deviation is 1.3, you can see that the mean is 1.9, so the average household has about 2 children. You can't have 1.9 children. And your standard deviation is 1.3, so most of the households differ from the mean by no more than 1 child. And that is it, and I hope you enjoyed.